So, can you hear? That's the question. Anybody in the chat? Anybody in the chat? Yeah, just give me a sec. Okay, hello?
Okay, awesome. Let's see. You want to do a problem?
Yeah.
Let me see if I can find the problem. Seems good.
I am live right now. So the people can hear you. Well, there's nobody actually watching, but just letting you know that you can be heard right now, but not seen.
Okay, sounds good. Let's
Um, not really, honestly. I think I'm more just like trying to practice anything. I don't even know if I'm really going to recruit this season because we'll see if I can try and just get a full-time here, honestly. But I need to stay sharp anyway, so
yeah, that makes sense.
yeah.
Let's do this problem, but I'm going to
Sure.
this is a problem description, and then I'll change it so that instead of if I like this, I just put them in different. We're up P2 return P2D or that where elements Manhattan distance. Manhattan distance from that cell to closest. And this closest is already applied by minimum Manhattan distance from that cell.
Sure. All right, so I'm just gonna start to read the problem. You are given a zero-index 2D matrix of size n by n, where R, comma C represents a cell containing a thief if grid RC is equal to 1, an empty cell if grid RC is equal to 0. You are initially positioned at 0, 0. In one move, you can move to any adjacent cell in the grid, including cells containing thieves. The safeness factor of a path on a grid is defined as the minimum Manhattan distance from any cell in the path to any thief in the grid. An adjacent cell of RC is one of the cells. Yeah, so it's just up, down, left, right. The Manhattan distance between two cells is equal to A minus X plus B minus Y, where val denotes the absolute value of val. Sure. Return to 2D array where elements in row R and C is equal to the maximum Manhattan distance from that cell to a cell with a thief.
Yeah, so as I
Yep.
so there's like I got my input grid, and then it's very important to look at like what the output grid would be. Like just would be
Mm-hmm.
so it's like output for that particular. And then
It would also be 0.
because
Assuming that the other one is still 1. Yeah.
so like the original values on which cells I need so this cell would be 1. This cell would be 2, right? Steve, but it's like vertically 2 away from the left bottom corner.
Yeah.
When it is closer to the
Is 0.
Only move horizontally, vertically.
Yeah.
Diagonally. So, like here, you can either like go up 1 and then to the left, or go down.
Oh, okay. Yeah. I see.
This is 2.
Yep.
And this is 1, I think. And then this is 0.
Okay. So my immediate thought process is that this could be some kind of depth first search problem.
Okay.
Where you're connecting all of the chains of thieves, and like I guess it would almost turn into like a graph with like a weighted direction, or maybe it would be like a graph with unweighted, or sorry, directionless but with weight, maybe.
Okay, so a weighted undirected graph.
Yeah, a weighted undirected graph. Yeah, and I'm thinking that like as you find the path. Yeah, I'm kind of thinking about some kind of weighted undirected graph.
Weighted graph.
Yeah.
I kind of see what we're doing in that graph.
It would be the distance to a thief, right?
I see. Well, that could be represented as edges, right?
Yeah, actually, yeah. I guess the nodes would be the actual cells.
So node cells and the edges. nearest.
Yeah.
I guess like how would you determine what the nearest thief is?
Yeah, I'm guessing like if you start from, I'm like looking at this example like it's the one way to do it, but you could also start in a cell that has no thief in it. I
I
guess,
don't think representing a graph is a bad idea. Though I guess instead of you,
yeah,
and then each of those edges would technically have to be one, or it'd be a
I guess, yeah,
yeah.
yeah. So I guess we can just say nodes is equal to the cells, edges is equal to just like the distance to the nearest thief, I guess.
And this would also be like to the adjacent cell.
Yeah, to adjacent cell. So, yeah.
And in terms of like BFS or DFS, then I mean you can mark the nodes that are specifically these as especially
Yeah.
BFS and DFS for those cells. Right?
Mm-hmm. Yeah, so I guess we could start at a node, and if it is a thief, then we keep its own distance as 0, but we add 1 to all of the neighbors.
Yeah.
And then I guess we could explore each one of the neighbors after that, and then continue on until you get to like the length, or you would get to n or n minus 1, n minus 1. Yeah, so I guess that's one way that we could do it. And I'm trying to think if there might be a better way.
So I think it's okay to think about this as a graph problem. You don't have to. So, like, matrix.
Yeah.
Matrix.
Yeah, so I think I might go with that approach.
Okay.
That's the first thing that comes to mind. So I guess we can just say, thief distance or thief dis. And I guess we're going to just have like a matrix, which we'll call cells. And then we're just going to have yeah, that would literally be the entire input, right?
Yeah.
Yeah, so I guess from here we could start by making like a visited set.
Right.
And this is just equal to a set. And from here, I guess we would need to I'm thinking if I need to make another matrix that's of the same size as the input matrix, or if there's a way that we can just change the input matrix on the fly.
Yeah, I think it's fine to. I mean, technically, it's in place, but at least you can just assume that it's okay to make it up.
Sure. So I guess we can just make a output array, which I guess we can just make a array. I guess we can make it something like 0 or like when.
And one thing you can assume is that this is a square matrix, so you're going to assume that we're going to.
Yeah. So I guess we can just say like something like this, where it's like 0 times len times 1 cells. I don't know if that's the right way to do this.
I think it's close. You could do something like or I guess you could do I think this would be
Sure. Yeah, that works. And then I guess from here we can just go for I in range len, or maybe we can do something like this. N is equal to len cells. And I guess from here we can kind of just we could do something like this. Maybe we can do like a directions. Do you have it like highlighted? Is that like you?
so yeah.
We could do something like this. Maybe we can make a directions array outside of here. We can make it something like 1, comma 0, negative 1, comma 0. And we can have like a 0, comma 1, and then a 0, comma negative 1 for I in range n. I guess we need to make like an actual function. That's something else. I guess we can just call it DFS. I guess BFS.
Instead of doing overlaying the function, can you implement it iteratively?
Yes, I think we could. What's going on, Geo? So I guess we could just do like while, I guess, would we use a visited set or would we use like a queue and also like both maybe?
Yeah, for BFS we're gonna use both.
Okay.
And there's actually a queue.
Oh yeah. Yep. EQ. And then wall. I guess wall Q. Maybe we can define these directions out here.
Good. So
Yeah. Like zeros? No. Well,
it should be popular. Well, initially we said that like we can make it matrix to the graph.
Yeah.
To the cells. So the queue should essentially be populated with the cells that we want to start from, or like the coordinates of the cells that we want to start to search for.
So I guess we can say DQ of cells of 0, 0?
Yeah, that would somewhat work in this case because first, so, as long as
You mean like integers? Like, what do you mean?
I mean, like, we have two different types of cells here. We have the cells of these cell that are just like normal. Right?
Yeah.
These cells marked as value 1.
Yeah.
Like, given that, like, where should we technically start the search if our goal is to find since we have the distance to the cell with the thief?
I guess we could just start with the cell with the thief in it.
Yeah. So.
Yeah. Yep.
Like, probably have the key with these two spells to start off with. Do you remember the undirected, unweighted graph? Like the closest cell, like the initial cells that you explore during the reference search.
Mm-hmm.
So, the reference search, we start from the cell in the top left corner. It has two adjacent cells essentially. Like the directions are going to include like this first one to the right of it is one.
Okay.
So that's a long-winded way of saying that we should start our search for the cells of the key. Our coordinates of the cells.
Is there some sort of list comprehend? Well, if it has a 1 in it, I guess.
Yeah. You don't use this combination. Let's say we can do this with the initial grid. And like we do it so that.
I guess we can just do something. I'm already getting some code duplication here, but we can do something like if cells of I j equals, is it like a 1 int, or yeah, it looks like a 1 int. Then q dot append cell, or q dot append, I guess we make it a tuple ij, right?
Yeah, that sounds great. Okay, great, awesome. Okay.
From here, it's like we should then go check into every coordinate that has a thief in it and update, I guess, the surrounding cues.
It's easier than that. We just do this.
Okay.
But let's say, like, each time we do BFS, we essentially keep track of, like, the distance that we have.
Yeah.
So let's say we have to do this. And like the idea is like
Oh yes.
like at the end of the process you update.
Something like this, like I guess maybe we can say like I comma j is equal to yeah, q dot pop left. Guess we can say for r in range I, and W in, or I guess C in range C, then for DR DC in directions.
Yeah, this is the right idea. So I don't think you need to do this.
Okay, sure.
I'm not sure why you're doing this. Unless you have a reason why.
No, I do not.
Yeah, but this is essentially the right idea to go to the neighbors.
Let's say R and C. I guess we would just want to check all of them.
Yeah.
So just cells of R is equal to, it would be like it's, or it'd be like plus equals like Q, or cell of RC.
Well, it would just be plus equals distance, right? Like the distance, because we always have that much.
Yeah. I guess what is the distance? Like we're going from what to what?
Yeah. Let's go to this example again.
Like we're taking the Manhattan distance. Yes.
So like, let's say we're just focusing on right?
Yep. Right.
Like each time you pop them, you like this per element. You should really set
I guess.
And doing this work set zero, right? So when we like the starting cells from the cube, then like the distance is just equal to 0, and it's like correctly then these two nodes will be zero, right? But we could be correct, right? And then ultimately we add this. This cell to our cube. And with each of these from the cube, that means that each of these distances will be correctly arranged. This one is going to have this.
Oh, okay, sure.
And then same idea. Next time we add this one, and then this one. This middle one is very equal to. This middle one is very equal to. And then if we did this and then figure for
Yeah.
So this is like this. Straight like this. Yeah.
So is it?
I think you're close here. Really, you just want to do this. R, C.
just like this? Or however I had it. Do I have it as like a list? So literally just this?
Yeah, for the most part, this is correct, though. You're forgetting your visited set.
Oh my gosh. So I guess that would probably be like the first thing we do, right? I guess we could do it after this.
I think it's usually better to mark it as visited after you've added it.
Sure. Like this?
Typically, I guess R plus
Yeah.
and then C plus DC. And then one thing you didn't check for is like if we were already text.
Yes.
So like I guess like you're going to each neighbors here.
Yes. There's like a way to do this, I guess.
Yeah, basically you're checking like if an element isn't visited, right?
Yeah.
And then what would I guess go ahead and set it to like?
It's like if R plus dr C plus DC
Yep.
invisited, or I guess not invisited.
Yeah. Yeah.
And then this plus equals 1. And I guess literally from here, we also need to update our output cell.
Sorry. Yeah. Well, this is a slight mistake. This should really be out.
Yeah.
Right? So you've updated like the output cells here.
Okay. And then would that literally be it? So return out?
Yeah. There are some issues with this translation.
Yeah, I bet.
Even though it's in general the right idea. One. Let's see.
Ah, yes.
For a corner, in each case, you can't move in every direction.
I guess it's like and R plus dr less than N and C plus DC is less than N.
Yeah, right idea. It also has to be greater than 0.
Oh, yes.
Alright, greater than 0. Let's do this. I don't know. I think you have greater than any here. So plus than. Let's see. One thing.
Yes, of course. Wall Q.
So you're doing wall Q, but you only probably one element at a time, right? Before you update. So
Yeah.
you have all the current elements in the queue.
Yeah.
Like the first two elements that are like these first two cells of one. Right? This one and then this one.
Yep.
The way you go kind of without this element too.
Yeah.
So like things initially like to right to start out, it just takes these first two cells. Like iterate like 2 times, right?
Yes. sure. Yeah, I definitely forgot how to do this properly.
Yeah. This algorithm, or do you know what this algorithm is called?
Yeah, this is just BFS.
Yeah, but specifically multi-source BFS.
Multi-source BFS, sure.
Is, in general, the BFS, you only have like one starting node, really one source.
Yeah.
But you've added like two initial elements to the queue, or it wouldn't necessarily be good. There's like four cells initially to the queue, right? That's BFS. We have multiple sources here instead of just
Mm-hmm.
which is like what. Okay, let's see how this works.
Yeah, let's see. Multi-source BFS.
Are you familiar with the problem of rotting oranges?
Yeah, I did that in prep for the Amazon interview, but yeah, I remember like there was something wrong with it that I couldn't do properly because there was just like this distinction between that and like number of islands. Yeah.
The distinction is that it's like multi-source.
Yeah.
We have some bugs here.
Oh no.
Most hurt.
This plus equals 1. Yeah.
So 0, 0, so like a mission cell is that equal to the distance of 2, right? And then if you
Less than n.
So it has to do with the distance.
Okay. Not invisited.
Sorry.
Oh, at the start.
So
Okay, and yep, you're just again just like look at this vibe coder, man.
Yeah, that makes sense why we need to add it here.
Yeah, because as we initially go through and we're checking those things, like in the first iteration through every single cell.
Okay, perfect. There's still some mistakes here. Okay, it looks like our thing fits right. It's a weird error. Let's reprint. Okay, this looks like that. There's looks like it's used
The plus equals. Badass chat. Says this does not create n independent rows. It creates one row list and repeats that reference to the same n row times. Yeah. So it says like this. Yeah. Yeah, that's so easy. It's like I know what's going on here. I just forgot how to actually do it properly. Yeah, but I see now. I guess is the only difference between a multi-source BFS is that you have to go through the initial array and add everything to the queue.
Yeah, exactly.
Yeah, okay, yeah. That makes sense.
Multi-source BFS, when they have this part, you should have like a small to a queue.
Yeah. Okay, I see what's going on here. Do you want to do a problem?
You want to do another problem?
Do you want to do a problem?
Sure, honestly. I don't know if we'll be able to solve it.
Yeah, that's fine.
But a medium.
Yes, sir.
About the Jalen Brown trade?
I don't know. It's tough to say because I feel like I can understand the reasons why it was done, so they could, maybe offload a longer contract extension, and they can have the optionality to do different things in the future. But I just think it makes them less competitive for a championship, which is what, in my opinion, they should be shooting for with everything in right now.
Yeah. I mean, that was a very weird trade, to be honest.
Yeah.
Yeah, because it's like the Celtics just won the championship 2 years ago. Their first win.
They made it far.
Yeah.
Yeah.
It's probably not one of the top 50 most impactful players.
Yeah. It's like for some reason, it's like I just don't think that Jaylen Brown.
Just from the analytics, even the eye tests.
Yeah.
He's clearly a very talented player. It's just like in a team environment, there's definitely like better players than him.
Yeah, it's like he doesn't make his teammates as better as he can.
Exactly, yeah. And he doesn't really draw like. It's not even just about like passing too. Like he doesn't really draw like defenders towards him, if that makes sense.
Yeah.
Right? Like I don't think that team is going in, trying to like double team Jaylen Brown the whole game.
Yeah.
It kind of reminds me of like Russell Westbrook. When Russell Westbrook was a better, more talented player, right? Like these players, like they can lead a team to like 50 wins, like make the playoffs, maybe even like win a championship as like the second guy on the team, but like people think that they might be the best player, right, based on the stats.
Yeah.
But it's like these players, like they're good, but they're not that good. They're not like an SGA or Luka, right?
Yeah.
It's like clearly they have like a very much outsized impact on the team. I don't know though. Like, I don't hate the Jaylen Brown trade. I just like don't like how they just traded for Paul George and like 2 first-round picks.
Yeah, it's like I keep seeing these reports that are saying that they had a real Giannis offer on the table, but I'm just like, did they really say no to a Giannis for Jaylen Brown trade? Assuming that it didn't also include like Peyton Pritchard or something. Like send anybody at that point.
I mean, the reports were that they didn't want to trade Hugo Gonzalez.
Bro, if that's really real, that's like the most ridiculous thing I've ever heard in my life. I can't lie.
Yeah, I don't think that's okay. It's the Miami offer. The Bucks just thought it was better. Dude, I don't think the Bucks really want to compete.
Yeah.
It's like Jaylen Brown would probably be a player that he's better than Tyler Hero. Right?
Mm-hmm.
We'll see. I mean, the Sixers honestly should at least make the conference finals next year. Assuming no injuries. But we shall see. Okay.
Hold on. Let me find this problem.
I thought the Giannis trade was terrible, to be honest, though.
You think so? I don't even think it was that bad.
I think the Bucks look like are kind of fleeced.
I don't really think so. I think they have a future still. Khalil Ware is pretty good. Jaime Jaquez is also pretty good.
But Tyler Hero is like the best player. I didn't know. I mean, I actually don't think the Bucks came out that bad. I didn't hate for them the trade didn't really make that much sense.
Yeah.
Like, I get that they wanted Giannis, right? They probably just want to do something completely different. Given that they really haven't done anything like the last few years. But the Heat have no depth. And honestly, at this point, I think Giannis is still going to be able to put up the stats, but I think these teams are kind of end up like the Kevin Durant teams.
Yeah.
Where it's like, it doesn't just take two players to win in the NBA anymore. You need a well-rounded team. If Miami gets LeBron, that's a good third option.
I don't think he's going to go to Miami. I think he's going to Cleveland. Yeah.
You really should go to Golden State.
No, I like him to the Timberwolves. I like him to the Spurs.
That's kind of boring, though, to ring chase. I mean, I think he would fit very well in the Spurs, right? But if he's on the Spurs, like, do you really need De'Aaron Fox then?
You really need what?
De'Aaron Fox. If he goes to the Spurs.
You might as well just keep him.
Yeah. The LaMelo trade I also didn't think made any sense for the Timberwolves.
Really? I think it made a lot of sense for the Timberwolves. I think it did make sense for the...
I'm very low on LaMelo Ball.
Really?
Yeah.
I'm actually quite high on him.
He just doesn't have the IQ. It's like, even like, I get what he brought to the Hornets, right? But it's like, he takes the most ridiculous shots every game, right? Like going 1 for 15, and he's like, you're 2 for 12 Literally like a top 10 player in the league, right? And definitely could throw like right?
Yeah.
You know, Nasri, Julius Randle, and Rudy Gobert. Now, like who do you like Jordan Behringer? Behringer? And LaMelo doesn't play defense.
Yeah, Gobert got him.
It's like the Timberwolves, they're such a good defensive team, and it's like I don't see them playing that much defense next year. But even Ant didn't play that much defense this past year. He just had, you know, good defensive players around him, and McDaniels, right? You know, Randall's a decent defender, Gobert, Dante DiVincenzo, but singly linked list group all indices together, followed by the nodes of even indices, and return the ordered list. The first node is considered odd, and the second node is even, and so on. Note that relative order inside both the even and odd groups should remain as it was in the input. Most of this problem in O1. Extra space complexity. Let's see. You've got a good drawer in. Okay.
Just a sec.
Okay, you can just screenshot it and drag and drop, I think. Sure. Okay. This is what it looks like. Okay, awesome. First problem, let's see. Okay. Yeah, this makes sense. I want to use some pointers here. Well, there's a few ways you could actually think about this, right? It's like, I'll move this over here. So the audio indices should always be at the front of the list, right? Actually, if looking at the problem description to make sure, it says group all the nodes of audio indices together, followed by nodes of indices. Yeah, the nodes that should be odd should be at the start of the list. And really, the problem is just about taking the indices and moving them to the end of the list. So we're gonna want to have a pointer at the end, right? I don't want to draw it like this. Is it? And this point. Great. Kind of bad needs to fix this. What does that mean? But basically, I want a pointer at the end of the list, right? And then each time we add an element, we want to keep moving that pointer forward, right?
Yep.
And then we're going to want to have a pointer that's on every even node, essentially. And then, actually, we might actually want 3 pointers here. So, like, initially, we would have a pointer on this even node, and we would have this pointer here. Because we need to, like, switch the connection, I think. Or do we? Well, actually no. We really don't need a pointer there. What we really want is a pointer on, like, the previous element, I think. Because we want 1 to connect with 3, right?
Mm-hmm.
And then we're going to want to move 2 at the end. And then we can just change that pointer to be the null pointer. So 3 pointers makes sense here. So essentially, like an end pointer, even element that moves at 2 times, twice each time. So like after we're done with 2, but then, okay. I see. So after. At least, right? Set that to. Side without 1 and 2.
Okay. Let's see. Yeah, I think so. But I could just be saying that because I have no idea.
Let's go class.
Okay.
And I believe like value, and then the next equal to none, and the value and just say yes. And then so next say that it's this is now.
Mm-hmm. That makes sense to me.
So where like the first value is basically sent a null node is just used.
Mm-hmm. Mm-hmm.
Yes. So
So are you sure about this like trying to move the nodes as opposed to, maybe making a separate list?
I guess we could make a separate list here, but it does.
Okay, sure.
I mean, if you want,
But wouldn't that still be O of one time? But it would just be O of n space.
well, it says all of one's extra space complexity.
Oh shoot, never mind.
But it depends on what you would like to see.
No, 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 no. Do whatever.
Right. So the next is current updates. And now we want that pointer not x equal to you do set x equal to current dot next. I think we want to set to equal current dot next, and then current equal. Yeah, I think that makes sense.
Hmm.
To engineer better. I think that's
Hmm. When does the loop stop?
Let's see. So here, I believe. So there are the. Which mean? And I like you. Yeah, number 0.
Sure.
Using integer division.
Yep, that is true.
That makes sense to me. And I calculated n already. So we'll just do you have a calculator here.
Okay.
Before I run this, there's a little bit of testing that I want to do. Then we just the next. First, I want to just make sure I'm counting. So reorder at 1, I think. That's good to me.
Sure. Yes, that looks pretty correct to me.
Then print LL to list. That one again. Or just return that list.
Yeah.
And list node.
Nice.
And this one, I suppose, and make this easier, I'll also do a function list to LL. And then if list equals 0, and we can just return. Not.
Nice.
We'll do list hopefully this is correct. Yeah, that was correct.
Yeah.
To me, unless you have any other follow-ups or even mistakes somewhere.
Oh, that looks correct to me.
Awesome. Am I getting the offer?
Yes, you are now at Big Tech LLC for 250K starting with 500K of RSUs spread across 15 years.
Sounds great. Sounds great.
Yeah.
I'll start on Monday.
Nice, nice, nice.
Okay, perfect. Have you done this question?
No,
Okay.
I just wanted to review linked lists, honestly.
Did my approach make sense?
Yeah, it makes sense.
Is there a better approach to this though?
This is saying that like the Sential node isn't necessary, or the sentient node isn't necessary.
Yeah, I think that's right. Yeah, it is technically not necessary, but you need the properties here. Or no, the reason it's not necessary means I can just return it.
Yeah.
And I think that would work. Yeah.
No, I think it's pretty good. Yeah. Welcome to Big Tech LLC.
Thank you. I can't wait to get started. Coding. Like lessons. Great.
Yes, that will be your entire job.
Yeah, definitely very relevant to their job.
No, not at all, actually.